Okay, so hi, my name is Jay Compton. I am the VP of Engineering for Healthogen, which is a healthcare technology company that was founded and spun off by Aetna Insurance Company and is focused around building new, innovative, and disruptive technology solutions in the healthcare industry. This is intended to be a primer for a talk I'd like to give at Velocity in New York this year, as well as to illustrate some of the value I believe the audience will derive from it. So the intention of the talk is to focus around the engineering principles, the technology practice, and the culture that we have leveraged within Healthogen to evolve the development operations team from being focused solely around that topic to working through supplemental product engineering and reliability engineering to actual product development engineering. So when Healthogen started, at least from a technology perspective, our CTO had a clear direction on where he wanted to take product development. So instead of focusing on methods like waterfall and big design up front, or developing software in a vacuum, we we wanted to focus heavily on design-oriented thinking to solve problems, as well as leveraging user experience design heavily up front, and product management following that to ensure that we guided the product development process in the right way, and using agile engineering techniques to build product quickly, to release often, and to learn from that so that we could iterate on those products. Based on the fact that Healthogen has a commercial business segment made up of existing larger businesses and an incubation segment, which is charged with building new products that will be catapulted either into new businesses or existing commercial lines of business. I challenge the executive team to look at how we would need to build a new operational model to support that. So, leveraging DevOps principles, for example, and software engineering principles to build an infrastructure product that the product development teams could use as both a development and runtime environment to allow them to gain some economy of scale in that space and not have to worry about things that would not provide their product development process with much value, like security and compliance of the systems they were running on, and having to deal with how that was affected in a cloud environment, for example. So we were also leveraging a lot of new technology in our space at that time, Ruby and Rails, native and mobile web for iOS and Android, quickly moving into front-end development with things like Angular. So we needed to be able to build something that was highly adaptable as well and would be able to meet the stringent requirements of a regulated industry. So my basic premise initially was that with the right team of engineers and the right engineers and the right team and the right culture, uh, by applying the software engineering practices that we used to build any other software product, we could actually build an infrastructure product that was managed in a very similar way and was highly tested so that we knew what we were doing was deterministic. It was idempotent as well as being flexible and scalable as well as durable. And so what we actually did was we looked to apply test-driven development and behavioral-driven development to building that product. So we use real things like RSpec and Cucumber to actually run those tests using Jenkins against systems that we built in a virtualized sense using Vagrant and Amazon Web Services, and with configuration management being handled by as excuse me by handling configuration management, for example. There we go, with Puppet. So those using those technologies to actually support those principles that we were looking to apply to building the product. And the what we found was we learned a lot really quickly. No two development teams are the same. No two developers are the same. So we found that a lot of the initial assertions and assumptions we made, like managing RVM in a Rails capacity for those teams on their systems, was a bad idea. They wanted to bring their own version in a lot of cases, especially as you got to the point where Rails 4 and Ruby 2.0 were released. So how could we adapt the system to allow for that level of flexibility? And then how would we actually engineer that into it so that we could let the developers have that level of freedom? So at the same time, the commercial segments in our business were noticed some of the things that we were building and how that automation and that level of engineering might be something that was valuable to them. So we started looking at how we could apply those principles based on the fact that we'd actually engineered by example to those businesses. So then, given the fact that we had software engineers following that, we actually found that we were able to apply those paradigms and those patterns that we used in the development of our platform to building things further up the stack than in the infrastructure sense. So looking at how we could build shared constructs for authentication, for example, was something that was useful to the product development teams because no two teams did it the same way. And those all had to be vetted by security and compliance to make sure that they were able to be released out into a public sector. So we found that by having the engineers that had actually worked on those routines and embedded with the teams, the product development teams, we had a really deep understanding of the product and were able to actually help them to implement what they needed from a security and compliance standpoint. So, lastly, looking at the culture that we look to foster and how we fostered it. So, building a highly diverse team that consisted of a variety of different engineers that were all focused on software engineering in an infrastructure space is something that I think is immensely valuable for other teams to hear about. The way that we actually brought the team closer together so that they operate as a singular unit, were empowered to make decisions, and didn't need to ask permission. They could act and make decisions themselves to make our software better without a lot of overhead. And then based on some of that learning, how we actually evolved the system to where it is today, from our initial assertion that I mentioned a few minutes ago in terms of what a platform should look like to where we are today in refactoring that system and actually adding features to not just handle applications but to handle data as well, right, in a large capacity, given that there is tons of data in the healthcare industry. So and that we've has been lovingly named Jarvis by our team for the Iron Man fans out there. So those are some of the topics that I think would be very interesting to cover for the audience at Velocity, with real examples, real code, real working software. It's not, I don't believe in slideware, so they're going to see actual working demos of these things as well as some of the other topics that I walk through in my abstract. So I hope that's a good enough walkthrough of the abstract for the chair committee. And if you have any feedback, please let me know. I'm always willing to hear it. Thank you.